Hi, my name's Dominic Barlow and welcome to C4. Currently this is the main tunnelling site on the project. We're building a 3.05 metre ID tunnel from this shaft running through towards shaft C8. This is known as the interceptor tunnel. As you can see, this is a very busy site. It's quite a small site. If you look over here, we've just received a delivery of tunnel rings. We have our main ring storage area over there to the right. You see the skip coming out of the shaft now, being moved by the 100-ton crane. Behind that crane, we've got the grout silo and the grout batching area, and then we have the spoil handling area here behind me with a 13-ton excavator in it. You just watch now, you'll be able to see him tipping the skips. Look at the Sumitomo crane. This is how we lower the rings down the shaft. You can see we stack the rings on the bogies and that's set up for going down the hole now. Behind me here we have the electrical substation, switchgear, and then down here we have two of the tunnel Shoma locos which are currently being serviced. Right, this is a 3.05 ID tunnel ring. It's a 6-plate trapezoidal ring. It's got 27 bolts which hold the ring on the seat joint, which is this joint, and the circle joint, which is this joint. In the middle here we have a grout socket, and this is what's known as a non-return valve in it, which means we can blow grout out through the back of the ring and nothing should come back into the tunnel. We also lift these segments using a lifting ball, such as this one. These screw in till they're tight, and then a rod goes through here and attaches to the front of the segment to stop the balls from spinning. When you're on the machine, you'll see on the segment erector there's a claw which attaches onto this, locks over, there's two stabiliser rams, and then we lift the segments up and build them in the tunnel like that. Currently stood in the back shunt tunnel. We use this to give us extra room in the pit bottom so we can empty the trains quicker. We're just about to see the boys lift one of the skips up with the bridle. This is a spoil that we're excavating at the moment. As you can see, there's quite a high water content in it. If you see the strings which are in it, that's actually the polymer which we use to condition the spoil. So the rock breaks down in the head and forms like a sand or a sandy paste. We use the polymer to bind it, and as it progresses out the tunnel on the trains, it starts to dry into this material. And then when we get it up into the muck bay, we can get quite a dry medium out of it, which then benefits our muck away. This is one of the Clayton locos. They're a 3.5 ton electric loco, and this is what we use to shunt in the pit bottom. We've currently got two of these in the tunnel, and they're used to bring the skips and the services to and from the main Shoma loco. These are the tunnel services. So on this side we've got water running to the machine, water coming back from the machine, and then we've got an airline. Okay, this is the rear gantry of the TBM. This is the main tunnel ventilation. So this air has been blown in from surface back at C4. We're now around about 920 metres in from C4. Bring that back, yeah, go. Very well. These are the services. We've got air and water going in. This is a pumping main. And this is the HV, it's 3.3 kV. As you can see here, this is where we're filling the tunnel skips. You can see the muck's actually quite wet, it's more of a liquid, foamy liquid. We pump a poly-rich foam into the face in front of the TBM. This conditions a spoil. bits of foam, it helps to keep the water out. It also lubricates the cutting head and the teeth. We then pump a polymer called TK60 into the actual screw conveyor, and that is the strings which you saw in the muck before, and that helps then to consolidate the muck, and it binds the water and the muck together. So we're now underneath the gantries. This is where the train will usually sit. On the left hand side we have all the control panels for the ground conditioning system, the grouting system, the electrical panels, and all the pumps for the lubrication system for the machine. You see on this tray here, this is where the TBM cable is actually laid. So as we mine forward, we draw it out through this tray. This is a Leica 705, which is how we're actually guiding the tunnel. We set this up on the node stations, we reference a backside, and then we shoot targets which are actually on the bulkhead of the machine on 2 target boards. And from that the engineers work out the attitude of the machine and the roll on the machine as well. We can break that for where the actual nose cone of the machine is, to let the driver know where we're going. So this is the end of the screw conveyor. It's an Archimedes screw, and it draws the muck out from the planning chamber which is in the head of the machine. As you can see, we're actually getting a few chunks of it. You imagine this, we might be getting larger chunks in front of the TBM in that muck chamber, but then with the flights on the screw it crushes it down to a smaller size. You can see it's still very wet. This is the segment magazine area. Actually lift up, and they lift the segments up, which allows us then to pull the bogies back out of the tunnel.